Hello and welcome to another session in mathematics. In this session, we'll be looking at number-based conversions. But before we do that, let us look at the previous lesson. Welcome back. The lesson objective of today is 1. Conversion to denary scale. Teach you how to convert numbers from other bases to base 10. From other bases to base 10. That's number 1. Then secondly, I'll teach you how to convert from base 10 to other bases. How to convert numbers from base 10 to other bases. And then lastly, we'll look at conversion of numbers from one base to another. Conversion of numbers from one base to another. Let's say we have the base 10, normally called decimal or denary. Then we have the base 2. This is base 10. We have the base 2, which is called binary. Base 2. Then we have base 8, which is called octal. We have base 16, which is called hexaoctal. Okay, base 16. Now, let us go to the first objective: conversion of numbers from other bases down to base 10. Okay, conversion of numbers from other bases to base 10. Let's take some examples. Okay, we have a question on the screen. We have to convert 101101 to base 10. We have to convert 101101 to base 10. Okay. Solution. The first thing we need to do here is to number this. Let's bring it down here. We have 1, 0, 1, 1, 0 and 1, and remember it's in base 2. Okay, so we start. We multiply the base by the numbers here. So we have the first number, which is 1, times the base, which is 2, raised to power the remaining numbers. Apart from this one, how many numbers are remaining? We have 1, 2, 3, 4, 5. So 2 raised to power what? 5. We add our plus. Then we pick this. We have 0 times the base, which is 2. How many numbers are remaining? We have 1, 2, 3, 4. So raised to power 4 plus. We pick the next number, which is 1 times the base, which is 2. Raised to power how many? 1, 2, 3. Plus. We pick the next number, 1 times 2, which is the base. How many is remaining? 2. Plus the next number, which is 0 times 2, which is our base, raised to power 1, plus the last number, 1 times 2, raised to power what? 0. Since no other number is remaining, so it's raised to power what? 0. Let us start now. 2 raised to power 5 is equal to what? 32. Now 1 times 32 will give us 32. 2 raised to power 4 is 16. And 0 times 16 will give us 0. 2 raised to power 3 is 8. 1 times 3 will give us 8. 2 raised to power 2 is 4. 1 times 4 will give us 4. And 2 raised to power 1 is 2. 2 times 0 will give us 0. 2 raised to power 0 is equal to what? Anybody? Okay. 2 raised to power 0 is equal to 1. We call it the 0 law of indices, where anything raised to power 0 is equal to 1. So 2 raised to power 0 is 1, and 1 times 1 will give us 1. We therefore add the numbers. 32 plus 8 will give us 40, plus 4 we have 44, plus 1 here we have what? 45 as our answer. Is that correct? We have 45. And now it means that 101101 in base 2 is equal to 45 in base 10. Okay, one more example. Okay, we are asked to convert the number 645 base 7 to a number in base 10. We still apply the same procedure we used in the first question. So we have our numbers to be 6, 4, 5 base 7, and then this will give us 6 times 7 raised to power how many? 1, 2, plus the next one is 4 times our base, which is 7, raised to power how many? 1, plus the last number, which is 5 times 7 raised to power what? 0. Is that correct? Now we start. 7 times 7 will give us 49, and 49 times 6 will give us 294. Then we'll have 4 times 7. 4 times 7 will give us 28. And then here we have 7 raised to power 0, which is equal to what? 1. You remember? Yeah. Then 1 times 5 will give us 5. So our 5 plus 28 will give us 33, and 33 plus 294 will give us 327 in base what? In base 10. 327 in base 10. Okay, let's go over to conversion of numbers from base 10 to other bases. Conversion of numbers from base 10 to other bases. Okay, example number 1. The first example we solved in conversion of numbers from other bases to base 10, we got our answer to be 45. So let's convert 45 to a number in base 2. Okay, we have 45 here. What we need to do here is to divide 45 by 2. We'll continue dividing 45 by 2 until we get to 0. We'll continue dividing 45 by 2 until we get to 0. So we have 45 divided by 2. Now 45 divided by 2 will give us what? 22. Remainder 1. Is that correct? And then 22 divided by 2 will give us what? 11. Remainder 0. Right? 11 divided by 2 will give us what? 5. Remainder 1. Okay, and then 5 divided by 2 will give us 2. Remainder 1. Is that correct? 2. Remainder 1. And then 2 divided by 2 will give us what? 1. Remainder what? 0. And then 1 divided by 2, since 1 cannot be divided by 2, we then have what? 0. Remainder 1. And then we'll now pick the remainders from down to top. So we start with this. We have 1. Pick this, we have 0. Pick this, we have 1. Pick this, you have 1. Pick this, you have 0. And then pick this, you have 1 in base what? Base 2. Have you not seen that we converted this to 45, and now we've succeeded in breaking it down again to 101101 in base what? In base 2. Okay, example number 2. Example number 2 says convert 68 to base 5. Convert 68 to base what? Base 5. Okay, we apply the same procedure. We have here to be 68, and we have here to be what? 5. Okay, now 68 divided by 5, how many do we have? We have 13. Remainder 3. Okay, because 5 can divide 65 to give us what? 13. And then we are left with what? 3 as the remainder. Then 13 divided by 5, 13 divided by 5 will give us what? 2. Remainder how many? Remainder 3. Is that correct? Yes. And then 2 divided by 5, since 2 cannot be divided by 5, we now write what? 0. Remainder 2. And we still pick our answer this way. We have 2 here. We have the next one to be 3. We have the next one to be what? 3 in base what? Base 5. Now it means that 68 in base 10 is equal to 233 in base 5. Let's go over to conversion of numbers from one base to another. Conversion of numbers from one base to another. Okay, we have a problem on the screen. It said we should convert 8A 9F in base 16 to a number in base 8. Convert 8A 9F, which is in base 16, to a number in base 8. Okay, the first thing we need to understand is the value of A and F. The value of A and F. Now we are dealing with base 16. In base 16 has its digits to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 10 is equal to A. B is 11. C is 12. D is 13. E is 14. F is 15. Okay, and then I want you to note here that the digits in a number or in a base is equal to the base minus 1. Okay, to know the total digits in a base, you write out the base and then subtract 1 from it. So for base 16, we count from 0 to 15. We count from 0 to 15. 16 is not included. For base 8, you count from 0 to 7. For base 2, you count 0 and 1 alone. Okay, so the total number in a base is equal to what? The base minus what? 1. So that's how we have 0 to 15 in base 0 to 15 in base 16. And now they said we should convert 8A 9F to a number in base 8. So the first thing we need to do is to convert this to a number in base 10 and then divide it by 8. We get what? Our answer. So let us start. We have 8, 10, 9. F is what? 15. F is 15. We write down 15. Base what? 16. So how do we convert this to base 10? We have 8 times 16 raised to power how many? Remember, this is one number and this is one number. So we have 1, 2, 3. Okay, so raised to power 3 plus the next one is 10 times 16 raised to power how many? 2 plus the next one is 9 times 16 raised to power 1 plus the last one 15 times 16 raised to power what? 0. Okay, hope we're following. Then 16 raised to power 3 means 16 times 16 times what? 16, and that will give us 4096. 4096 then times 8, we have 32,768. Okay, let's continue. For this we have 10 times 16 squared, and 16 times 16, which is 16 squared, is equal to 256. 256 times 10 will now give us 2,560. And then the next one we have 9 times 16. 9 times 16, and that is equal to 144. And the last one we have 16 raised to power 0, and anything raised to power 0 is equal to what? 1. So 15 times 1 will give us 15. Is that correct? Yeah, so let us add up these numbers. Okay, we have the total of 35,487. 35,487. Okay, so this is in base what? Base 10. But the question said we should convert this to what? To base 8. We have to convert it to base 8. So what do? We have to divide this by 8 until we get to what? We get to 0. So we divide this by what? By 8. Okay, let's go over to the next page. We have our numbers to be 35,487, and we are dividing by what? By 8. So let us start. 35,487 divided by 8 will give us what? 4,435, remainder 7. Okay, and then 4,435 divided by 8 will give us 554, remainder 3. And 554 divided by 8 will give us 69, remainder 2. Okay, and 69 divided by 8 will give us 8, remainder 5. 8, remainder 5. And then 8 divided by 8 will give us 1, remainder what? 0. Right? 1, remainder 0. And 1 divided by 8 will give us 0, remainder 1. So we pick our remainders from down to top. So we have 1, the second one we have 0, and then we have 5, we have here to be 2, we have 3, and then we have lastly 7 in base what? In base 8. So the answer is what? 105237 base 8. I hope we are really following. Okay, we'll stop here for today, but so far we've been able to cover areas like conversion of numbers from other bases to base 10. We've been able to cover conversion of numbers from base 10 to other bases too, and then we've been able to cover conversion of numbers from one base to the other. Do well to use the lesson notes on the platform for better information on the topic we've just discussed. Feel free to drop your question on the comment section in case there's any area you are encountering any problem, or you can ask your teacher there in your school to help you out. When we come our next class, we'll go over to addition, subtraction, division and multiplication of number system. Till then, stay safe and bye.